Well, hello. Obviously, this is Don Heirman. What I thought I would do today is sort of describe a typical scenario of a professional life. And obviously, I'm going to leave behind the education part of it and sort of move on to going into professional life. And what I'd like to track is the history of one individual, but it may be applicable to many others. And I hope it would be helpful in others as they go through their career. So let me start with the first thing I did, of course, coming out of college. I had to get a job. And I also had a military commitment. So I found a job in Bell Laboratories that would allow me to finish up my 2-year active duty obligation in the U.S. Navy. I served in the Pentagon. It was a very wonderful experience. I was in the office of Chief of Naval Operation doing radio propagation study. And that was my subjects that I used in college in my undergraduate and graduate degree, waves and propagations and antennas and so forth. So I had a firm basis in the educational opportunities, which every one of us should have. And then how do you now put that into a career? So what I've tried to wind down here is to see how I did it, and maybe it might be helpful as a guide or an example to others. So let's start with Bell Laboratories' career, because I left the Navy 2 years after I was there for my active duty, and it turns out I stayed in the reserves and actually retired from the military in 1985. But nonetheless, in Bell Labs, what do they do with a young engineer? Well, they put them in a room and give you a bunch of things to read. And hopefully you come out with something of what you might want to do in the future. Well, that's kind of what I did. I remember when I first moved into a classified area, guess what? They couldn't give us anything to read even. So they put us in a room and we told jokes all day. Well, that's an interesting way to to earn a living, but it was leading up to the point where finally the classifications came through and I was able to start reading some documentations to work. And that's what I did. I started off with some projects with Western Electric, essentially on the YLS system, which is a tropospheric scatter radio system, and the part of the ballistic early warning system from across Canada through the Aleutian Trench. It was a very interesting activity. And then it came along that the Bell system was more interested in actually doing Bell system work rather than the military work, so that started to wind down. Again, this is another idea in your career. You will never be in one place in one area because simply everything changes, and you have to be available to do that, or be acceptable to do that. So there was one project that sort of transitioned that I got into. It was power line noise on the telephone system. Because back in those days, it was the first time they actually jointly buried power and telephone lines in the same trench. And as you might imagine, the coupling mechanisms were way back in the 1930s with Carson, and we actually used those equations even though it was in the 60s. And you only could go about, in those days, you only go about half a mile before the noise on the telephone system was so bad you couldn't hear dial tone. So that was one area of, I ended up taking experimentation in various places, noisy environment, the telephone plant, regular suburban, urban environment, and we actually did data recording of all the harmonics of the power line. We did it at the time of day, as day to day, week to week, and so forth. So we got a very good idea what that was. In fact, my first 2 IEEE publications were on those 2 subjects, which are still used today, because you can't afford to do the kind of work we did now over all those months. And along then came a crossover to one military project, was kind of interesting. This was Project Sanguine, which is the communication link worldwide to the Navy ships and submarines. And that was a project in the northern woods of Wisconsin. And there it was very interesting. We had an antenna, which was essentially a power line over the ground that had almost 1,000 amperes flowing through it. And that is one way to communicate when you have to have the overhead down to the Precambrian rock and back up again. You had a loop antenna. And guess what? The ionosphere was the waveguide. And one of the interesting concepts of there is, there's actually 2 or 3, but one that always interested me, We had to dump this almost 1,000 amperes into the ground. How do you design a grounding system where you dump 1,000 amperes? And the problem is, if you dump it all at once, you have a very high potential between your front leg and your rear leg, and that tends to be a shock. So we had to distribute this thing over a better part of a mile, mile and a half, just to spread out the current flow and the Earth's potential rise. That was one aspect. The other aspect is, as you might imagine, the telephone lines were very noisy. Some of them we simply couldn't break dial tone. So one of the things we thought of, and I actually did the calculations, is if we put in a transformer in which the primary is picking up the noise to ground of the telephone line and reversing it and putting it back in the telephone line, we'd have what we call essentially bucking voltage. So we had a sawtooth. It went up, we put the transformer in, it went down, and so forth. Well, without doing that, it would have reached 100, 150 volts to ground of 60 hertz. So we came up with these ideas, and it worked. We were able to get the customer to hear dial tone, and they were pleased, of course. But then we got complaints. What do you think the complaints were? Well, I couldn't keep my lights lit because you took away the power. They were powering it off the telephone line. And of course, it's a fairly high impedance source. And that occurred again in some of the work we did on the noisy loop plant, where we had a 100 kilofoot loop, and the same thing occurred. We fixed the hum, but then we destroyed some of their free electricity. Well, moving on then, I got into the compliance region, and of course the start was 60 hertz, and then we moved up to high frequency because in those days we were using cordless telephones, which was in the 47 megahertz region. And then we had speakerphones and the like, where audio rectification was an obvious issue. And in fact, we had really, most of our frequency energy in those days was under 100 megahertz, just under the FM band. And one of the things we tried to do is, how do you make a quicker test than using, let's say, a parallel plate capacitor or a strip line, if you want to call it. Well, we contracted with the National Bureau of Standards at the time, before it became National Institute of Standards and Technology. And they built a TEM cell that Mike Crawford himself built for us. And it was 2.8 meters by 2.8 meters cross section and 5.6 meters front to back. It had a passband of 120 megahertz. Absolutely perfect for what we needed to do. In fact, we used that for almost a decade, even though obviously the interference complaints went higher and higher above 100 megahertz. So the point being is, we had to measure compliance, and I was there, and I was my common knob twiddler in the lab, trying to see things to work. And in fact, later on, when the FCC Part 15J rules came out, I had to design very quickly an open area test site, and I did several of those designs. So your natural career kind of starts at one ebb and moves to another ebb. That's the low point. Then there's high points. Well, the high points, of course, is when you're fresh into each of the subjects. Well, moving on then to doing this for, let's say, many years, and you start building up your credentials, you start building up your expertise, you do continuous education and training, you get into a quality system where you have to show what you're doing is consistent, and eventually you may leave the laboratory and you go into management. And some people abhor management, but others don't. And in fact, it is a natural progression. And don't get rid of the opportunity if it comes around, because you can still get in the lab occasionally and do some knob twiddling and watch other people. But more importantly, you see how people, their career starts to blossom when they learn. They start from as an apprentice and move their way up to a very professional person. I know when I was manager of the Global Product Compliance Lab at Bell Laboratories, one of my concepts was that if a person was very good at what they did, number one, and secondly, took on an external job, which I'll talk about later, it turns out electromagnetic compatibility standards, that was a path to promotion. And several people took me up on that, and others did not, of course. So the technical management is a part of your career. It depends how long you stay. Hopefully your jobs will continue, but if they're not and you have to move to something else, well, you move to something else. If that one job disappears, hopefully you have enough credentials that you can move on to another job, perhaps with another company. I was very fortunate that I was able to stay with one company for 35 years before I decided to look at my next step. But before I left Bell Laboratories, I essentially gave up doing the managing because I wanted to be a senior consultant to all of the laboratories, and that's what I did. You get a chance to teach other people, you get a chance to answer questions. Again, this is a natural progression for those of you who stick around the company long enough. You start as a techie, work your way into management, then you work into senior consulting, and now you have to decide how long you're going to stay. And of course, if it's retirement time, it's retirement time. I got an offer to be an adjunct professor at the University of Oklahoma and to be the associate director of its Center for Wireless EMC. And I just jumped on that, even though it was in Norman, Oklahoma, which is just next to the end of the world. It was still a nice place to be, and I had a good opportunity there because we were built to handle wireless communication. There was cell phone communication impinging on medical devices, defibrillators, pacemakers, hearing aids, and the like. And those were the days, by the way, and this is talking about the late 90s, that those devices still had immunity issues that they had to work around. So that was another step now. Get a chance to go out and teach others, which is quite enjoyable for me because I got an opportunity to have some of the brightest and best in front of you, and you would be, well, you would imagine the kind of pressure you're under if the people in front of you are just snappy, sharp. And in fact, we had people from outside of the U.S. that would come in. They would know how to solve the electromagnetic equations, yet they didn't know what electromagnetics was. And of course, that's a nice mix. If you can just train them now on what they are doing and why they are doing it, and they have the tools to do it, voila, you're there. And I was able to progress that to, I think I taught at one point up to 20 graduate students. But the problem there was, of course, I was in New Jersey and that was in Oklahoma. And to get from New Jersey to Oklahoma, you can't get there from here, because you had to go through another airport. And it would take better part of 7 hours to go each way. So I have to tell you one story. When I used to land at the Will Rogers Airport in Oklahoma City, I tried to get in like 8 o'clock at night. Well, I got in 8 o'clock at night. This beautiful airport, it was built because at one point it was supposed to be a hub for Delta and American Airlines, but they pulled out. So there was virtually few flights going in. So I got this enormous airport. You get off the plane, there's nothing open, 8 o'clock at night. You go down to the luggage carousel, and you say a couple prayers to see if the luggage ever comes out. And finally it does. Then you trot over to the rental car place, and the woman sitting behind the counter says, "Thank God you're here, I can go home now." And that was it. They closed up the shop as far as I'm concerned once I landed. But anyhow, Norman itself, the campus itself is gorgeous and in fact, I still have my office there, even though about 2 or 3 years ago, I decided I just couldn't keep making the trips back and forth to teach an hour course. So what do you do next? Well, do you go to another business? Do you sit back and enjoy movies? Do you go fishing? Well, I'm not the type, and hopefully you, if you're not really involved in your professional life, don't want to do that. So I decided to set up my own company, Don Heirman Consultants, LLC. So my business was workshops, and along that time, you have to start thinking, what is your career going to do beyond just doing business for people? And that's where I got involved. Well, actually, I got involved much earlier on with the IEEE. That blossomed into the International Electrotechnical Commission. It blossomed into many trade organizations. I'm a member or an executive committee thereof, and so forth. So I'd like to spend just a little time on that because I think it's important for you to have something else to put your hook into than just the ability to go out and do a test or out and read a book. So one of the things I did is I started my IEEE work, which is kind of an interesting story, at least to me. I was at one of the Bell Labs locations in northern New Jersey, which is a 3-hour round-trip drive from where I live, in fact, where this film is being made. And that's all I could do. Go there, do my job, spend all that time in traffic, and come home. Well, one day I was able to finally get the transfer to the local Homedale facility here in New Jersey, and that's 4 miles away. All of a sudden I had 3.5 hours knowing not what to do with. Well, of course, a vacuum is always covered up very quickly. And I got a call from one of my friends, Joe Chislow, said, why don't you come to the local EMC chapter? And we've got a talk going on. Maybe you might like it. And you can realize when I left the Purdue University, I was not in the Purdue IEEE chapter. So I didn't even join the IEEE till 1973, which is well after when I graduated. So okay, why not? It's something to do. Well, within 3 years I was chapter chairman. I became section chairman, and with, I guess it was more like 8 years, I became president of the EMC Society in 1980 and 81. Who would have thought it? And again, what I'm saying is you don't have to be there forever, but if you're going to do something to your advantage or even to others' advantage, take them up on it. You got to have a professional career beyond what your work is. Otherwise, you have nothing to fall back, especially when you get into your retirement age or your near retirement age. So, given that, that was the 80s now we're talking about, and these were the exciting 80s, of course. Why? Because Part 15J came out, the IT requirements for personal computers. Well, that was a major thing. I have to tell you a little story because I was president at the time. In 81, we had our EMC Society Symposium in Baltimore in Inner Harbor, and there were, we have the usual session places, and the particular one on introducing 15J was in a room that maybe held 20 people. We had other sessions that we put in the ballroom because we had all this room, and they had like 10 people trying to watch this particular. So about midway through that session, people were trying to jam to get in because their boss called them up and says, you better be there because that's important information that's going to affect your product. Well, they were there, and because it was such a small room, people were actually punching each other to get in the door. Obviously, we didn't have to call the ambulance, but it was a tense moment, shall I say. Well, coming from the background of testing, you have to test to a standard. Standards make the world go round, whether it's for your product compliance or whether it's just for your product to interoperate with any other product, since most of the manufacturing today is taking parts from many vendors and putting them in a package, and hopefully the whole thing works. They do that because standards exist. So I got very much involved in the IEEE EMC Society standards, and at that time just called the Standards Committee. Now, of course, it's called the Standards Development Committee. And I stayed chairman of that for 17 years, a long time. Bud Taggart from NBS at the time, again, not before it was NIST, was my predecessor. I remember when I took over, he says, it's like pulling hen's teeth to get these people to do anything. Well, not a lot of that has changed, but guess what? There's a lot of pressure to get these standards out now. And that means you don't have to pull hen's teeth that much because they're in there trying to pitch in. So we had about a dozen standards at that time. They were all about 10 to 20 years old because we didn't have a requirement in those days. After 10 years, it disappears. It's administratively withdrawn. So some of the standards there was old technology, old instrumentation for calibration, and the list went on. So my job over those almost 2 decades is to bring those all up to date, which I did through obviously the participation of those working groups and the chairs that really pushed the material. And then let's expand our horizon. Let's get into other areas. We've got into computational EMI. We got into intentional EMI. We've got into filter design for high frequency and high energy use. The list continues to go on. And again, right now, at this moment, we're into smart grid. The control of the power system and how the energy is used both to and from the home. Because there is some storage capability that can put it back into the system when the home doesn't need it. How do you do this for the grid, which covers the entire country? And can you do it such that the instrumentation is immune to the RF environment that it lives in? And secondly, any emissions coming off of that, either conductively over the line or radiated from the boxes. What is that? That's called an EMC situation. And obviously, if people are worried about the communication channel, they're worried about the coding of the channel, and they're worried about the safety aspect, have they thought about the EMC aspect? And you can imagine the answer to that. For those of you that are looking on, that are in the EMC business, we always have to get our system and our idea and our thoughts in. And right now we're doing that. It's rather spoon feeding, but we think we have to do that. And the country needs that as well. And this is an international activity. And that brings me on to another link I have with the standards world of EMC. I'm chairman of CISPR, which is the International Special Committee on Radio Interference, and it is a technical committee of the International Electrotechnical Commission. These are the folks that do the technical voluntary standards that are applicable worldwide, because the people that vote on those standards and write them are from national committees. And right now we have roughly 25 national committees that are active in CISPR. And what I've been trying to do, and I've accomplished it in a couple cases, is to have joint projects with our EMC Society Standards Development Committee, so at least they can contribute in one direction or the other. And again, when I give a talk in the IEC CISPR, I always bring in, here's what's happening in the EMC Society standards world, or in any other standards world, whether it's SAE or you can name a bunch of other organizations that have EMC standards. Again, try not to be inward looking, try to be outward looking. You've got to come up with the next widget and the next way of moving forward. Otherwise you get bored. You simply get bored. And you don't have an opportunity to meet all these wonderful people that have like interest and are very cordial, and it's always fun to try to understand others' languages. If we're going to be international and the United States is going to have some impact, I then joined the U.S. National Committee of the IEC and all of their mirror committees of the CISPR committees as well as others. And soon I became on the Technical Management Committee and worry about EMC coordination amongst all those TCs, technical committees, that have EMC. For instance, the TC62 on medical instrumentation and medical equipment. They have EMC concerns, as we do in those committees that are only EMC, such as CISPR and TC77, which does the immunity and low frequency emission work. And if you start looking at it, there's about 7 or 8 technical committees that need that coordination. So what I did, I took over from Dr. Showers, the coordinating committee in the U.S. National Committee that coordinates all EMC activity among all the TCs that we are active in the international world. By the way, I want to take a sort of a side note. Dr. Showers has been my mentor in the EMC standards world for decades now, and I met him back in the late 70s, early 80s, but one of the things he did in 1984, 1985, he called me up and says, you know, we're having this CISPR meeting in Sydney, Australia. You want to come along? And I says, first of all, what's CISPR? Is that something you eat for breakfast? And what's Sydney, Australia? I've never been out of the country that far, other than maybe going to Italy. And he says, well, come along. He was chairman of CISPR at the time. And I said, well, okay, you know, might as well try something different, right? And found it to be extraordinarily interesting. That was back in the days we were starting to look at limits for information technology equipment, new instrumentation. It was just eye-opening, as well as being nice to be in Australia, because the people there are very friendly. We had one of the largest U.S. contingent, in fact, it's never been exceeded since then. We had well over 100 U.S. people there attending. Of course, now we're more in the order of 15 that can make it. But interesting, I said I liked it. Got involved in the basic equipment and measurement methods and instrumentation, and guess what? Measurement uncertainty. That was Subcommittee A of CISPR. I got very interested in that because that was part of my history. And again, for you folks that have expertise in a particular area, I guarantee you we could find something in the IEC that will fit your needs. The bug bit me, let's face it. And I became secretary of one of the working groups. I liked it. I became chairman of a working group. I became secretary of a subcommittee, chairman of a subcommittee, and voila, after 24 years, I became chairman of CISPR. Now, it took 24 years to make the #1 spot in CISPR. If you don't have the wherewithal and the urgency and the need and necessity to stick with it, you're not going to get to that kind of situation. And I think it'd be a real shame to waste your educational opportunities, your work experience, your expertise, your ability to do things, and not be able to at least have the opportunity to try to get up to the chain of command, if you will. And this is probably one of my highest pinnacles in my technical career, is being chairman of the International Committee on EMC. But along with it comes its rewards. 2 years ago, I received the Lord Kelvin Award of the IEC, which is the highest technical award that they give for professional activity in the entire IEC. There's only a little more than 20 people that have that. Dr. Showers is one. So again, I'm following behind my mentor, and no objection whatsoever. He's a close friend of mine, and even when I took over now the national side of that house, which is the ANSI Accredited Committee C63, he was the previous chairman there. So if I walk any further in his steps, I might as well try his shoes on. And as you go through your professional career, there's acknowledgments, and that can't help but boost your spirits and make you move further along. So if you do a good job, there's going to be somebody out there that's going to recognize it. I spend a lot of time recognizing people, writing endorsements and writing referrals, and I love doing that, and for whether it's a fellow or what. By the way, speaking of that, on the IEEE side of the house, I became heavily involved in the Standards Association, and I went up the line there as well. I started off as a Standards Board member representing the EMC Society. I moved then to chair all of the major committees of the Standards Association, the New Standards Committee, the Procedures Committee, and so forth. And what was next? Next was vice chairman of the Standards Board, then became chairman of the Standards Board, and then they instituted a board of governors which handled the administrative and the overarching business side of it. I moved into the board of governors, and then finally I ran for president of the entire association and made president in 2005, 2006. So again, that's another path in parallel with my international path, my national path, and my consulting business, which was still ongoing, which followed on with my formal education, the Bell Laboratories career, and so forth. I became a member of the board of directors of the Institute. Now I'm because all of the presidents of the major boards within the IEEE automatically get on the board of directors. And because there's only 6 major boards, and Standards Association is one of them, along with the Educational Activities Board and Technical Activities Board, for example, I was on the executive committee of the Institute. And there, some of the things that we did there was we started the office in China. I had trips that we had to go to China. We had teleconferences at the president would call a teleconference. Within 24 hours, you had to be on it. I remember it was one that he called when he was in St. Petersburg, Russia, and I think we heard every third word, but at least we were there with him and tried to help out because he had an urgent matter that had to be dealt with. But again, 2 years, you only have a term limit, and what do? You move on. I came back to the Standards Association, and they started looking at developing new products. What do you do with a standard after it is published? How do you handle conformity assessment? How do you handle brand recognition? And that became what they called a business development ad hoc committee. And they tapped me on the shoulder. I'm on all those committees now, following my main career being the head of the organization. It's hard not to follow in those steps unless you just say, I've had it, I'm going to go fishing. Well, a person like me, if you know me at all, I wouldn't even know when to spell fish, much less go fishing. And that's one of the reasons why I keep going on my consulting business, even though it's not near the level it was before, because it's what I've always done. And I am the type of person that have to keep doing that kind of work until I'm incapable of continuing it. Because in fact, it does keep you alert. It keeps your network going. It keeps your mind going. It keeps the ability for you to speak uninterruptedly, which I am doing right now, because you have to communicate your skills. And without keeping that moving, it just goes away. Even the work I used to do in the military that I did in spectrum allocation, well, ever so often that pops up. And I've done that for the military. I know the procedure that they use, and I could easily massage it into the particular situation. And my military career, by the way, I have to say this, was one of the highlights of my career. The 2 weeks for active duty for training had a lot of challenges. For example, I was able to do my training at the Naval Research Labs in Anacostia, Maryland, which is just south of Washington, D.C. And I was there in the early days, in the 60s, when in fact you walk into this candy store. They had near-field ranges, all these goodies. And this, of course, it was classified, but I was a military officer, so I got to see it. And that's the kind of opportunities that open up. And as I became promoted over and over again in the military, I made it up to commander, which is equivalent to a light colonel in the Army or Air Force. That was 20 years, and I thought that was probably enough. My poor wife, Lois, had to put up with, I had to drill every Wednesday night. I had to drill a weekend a month. I had to take 2 weeks active duty for training every year. And I did that for 21 years. And that meant that there was really no smooth, I had to schedule when I took vacation. And of course, I never took vacation really, other than going to another meeting. And if there was some time at the front or the back end, I would do that. And Lois, my wife, came with me most of the time early on, but then I started to repeat, and we went to 25 countries, and we were quite traveled. One of the things I would alert you to is I had a lot of friends that said, I'm going to get my career over with, then I'm going to retire, then I'm going to travel. Guess what? They lasted about a year or two, and they're gone. They never got the opportunity. So I'd say take the opportunity now. Do it now and don't let it go. And if it costs a few pennies, save up so you can do it. I've been to New Zealand, Australia, Japan, Singapore, Shanghai, Hong Kong, Beijing, all of those because of the standards operation and the IEEE activity and the IEC activity, because we try to hold our meetings around the world because we're a worldwide organization. Makes sense, doesn't it? A couple of things maybe to take away with this. First of all, think the long haul. Think you're going to start in a particular position in your life, and you want to advance. And if some opportunities don't knock, well, there'll be others that knock. You got to stick with it. In the standards game, if you aren't willing to stick in there 10, 20, 30 years, you aren't going to make your mark, or you're not going to get the full receipt of what is happening with other people that you work with. Also, make sure you have parallel activity. Don't just try to do focus one activity. I was in great shape the last 20 years when I had the IEC, I had the IEEE, I had my own workshop, and I had other jobs that came along, like building or designing major EMC test facilities, which I did for the Food and Drug Administration. So that keeps you focused, so that day one you don't say, I got to do only this for the next 3 months. No, try to split it up. Your family has to be part of this activity. If you are just doing it on your own without taking into account, especially your spouse if you have one, you're not going to enjoy when you have the leisure time to be with them. And that's a tough hoe. Nowadays, a lot of people have their offices in their home. Well, there's a couple of reasons. It's a little cheaper, for example, if you do your consulting business. But guess what? You're going to have interruptions. You're going to have to stop and be with the family if the family is still home. And it's a real challenge to do that. In my case here in my home, I actually built a office with doors that isolate more or less from the rest of the house. I changed a double garage into an office space and built another garage. But I was very fortunate in my life. My wife Lois worked at Bell Laboratories, and she was in the office of the vice president doing financial work, doing personnel work. So when I retired in '97, started my own, from early retirement, and started my own company in '97, she came right along and she was the secretary treasurer. It was just a beautiful fit. We enjoyed our life quite well. And we got out. It was lunchtime, we're out the door, get a sandwich, go to the park, go to the river, watch a sailboat, and we did it all the time. We didn't want to stick ourselves. In fact, it was kind of amusing. The other day we saw a place napkin that said, if you get tired of being in a house, come rent our office space. And who would have thought that that would be an ad 30 years ago? Because everyone was in an office. There was no telecommuting, so to speak. Do more than what your career is. Get into professional life and join something. I don't care if it's your church committee, but if it's something in your technical line, the IEEE, if you're a double E or a computer scientist, it's a great thing to do. But there's others, if you're in the aeronautics business, or you're in the automotive business, SAE for example, join a professional organization. And just see if it's what you want, and if not, you leave it. If it is, and you feel that you want to give more to it, maybe you might want to start going up the line and extending your professional career in addition to your technical career. And I think that's really the way to do it. Join, stick to it, and hopefully it'll repay you more full than what you could put in it. So with that, I think, thank you for your time.